Well, good morning, everyone. We are on our second unit. We are on Module 2. It is week 2 of the summer course, and we just left chronic heart failure. We were just looking at a fraction of the complications that can occur during chronic heart failure. And we saw how there are pharmaceutical therapies that will assist in kind of curbing the development and the exacerbation of that disease. And we talked a little bit on how exercise can help on arresting it and reversing it. So what we're going to talk about today is a close cousin to chronic heart failure, which is myocardial infarction, which is basically a heart attack. And there is a lot of overlap between these two conditions. Chronic heart failure had more to do with the pump just simply not being able to keep up and sending oxygen and oxygenated red blood cells through the rest of the body, nor was it good at oxygenating itself. And that's one of the reasons chronic heart failure leads to the failure of the heart and the inability for it to pump. So something to pay attention to is that when we get into these conditions or these diseases, there are all these compensatory mechanisms that turn on. And what does that mean? Well, it means that the body is really, really good at sensing changes in the way it functions. Now, the body encounters changes all the time, right? There's days you wake up, you're stressed. There's days you wake up, you're tired. There are compensatory mechanisms in the body that will help you kind of get through the day. Another example of that would be when you exercise. Whether we're doing endurance training, strength training, high intensity interval training, you are taking your body out of homeostasis. You are taking it out of the condition in which it likes to exist in which it is comfortable in, and you are elevating the demand of the body for 30 minutes, 40 minutes, an hour and a half, however amount of time that you're working out. Well, when we begin to work out, your body shifts. All these compensatory mechanisms get turned on, and that's what helps you stay in that exercise capacity for however long you're exercising, right? It makes sense. Your sympathetic nervous system turns on, your parasympathetic nervous system turns off. You have all of these different changes in endocrine signaling, right? When you start to exercise, you secrete glucagon and you inhibit insulin, right? So your body is in a catabolic condition where it is breaking down all of the energy that you had stored to help you with exercise. Your heart rate increases, your blood vessels dilate near the contracting skeletal muscle. You get an increase in blood pressure, right? You perspirate, all of the blood is shunted from your gut and your digestive tract to all of the contracting muscles, right? So there's these compensatory mechanisms that are at play during exercise, but they get turned off immediately after exercise. So that would be an acute change in physiology and an acute stimulus, which is the exercise. But then we have the other side of the coin where we have chronic changes and chronic illness, and the compensatory mechanisms turn on, as you've seen in chronic heart failure, and they stay on for longer durations of time. And these compensatory mechanisms, they start to cause problems. So when we have a condition that is no longer in the acute phases, but transitions into the chronic phases, well, because of that change in basal homeostasis and basal physiology, these compensatory mechanisms, they turn on, they stay elevated, and this causes more unfavorable changes in the body, right? We don't want the body responding to a disease for a long period of time because then the disease is the first domino, and then all the compensatory mechanisms are the other dominoes, and these dominoes all begin to fall, and they create more stress on the body. So I just want you to keep that in mind. So now that we're going to get into myocardial infarction, or simply put, a heart attack, we're going to get other compensatory changes that will occur as well and make this condition worse. So there is a lot of overlap between myocardial infarction and chronic heart failure. And I did this on purpose for the first few modules because, I want to essentially beat a dead horse. I want to stay in the cardiac conditions for a couple of weeks. So that way this becomes a bit more familiar to you. So when we have myocardial infarction, this is referring to the death of myocardial muscle cells. So these are the cells in your heart that begin to perish, and these cells are beginning to perish not by apoptosis, which is a programmed cell death, right? It's a controlled and regulated cell death, but this is occurring through necrosis, and this is occurring because the heart muscle cells are not getting the nutrients, most importantly, the oxygen that they need to continue contraction. And there will be, like I said, compensatory mechanisms that turn on. So just to kind of put your compensatory hats on for a moment, one of the things that will occur is that, let me get my pen out here. So when we have the heart, I'm just going to draw a heart cell, right? So this is a myocardiocyte. They kind of look like this, and then they look like this, and they're striated just like skeletal muscle, right? So this would be one myocardial cell. They'll have a nucleus. They are obviously contractile cells, so they'll have myosin and actin. Well, because this muscle and these cells are pumping all day long, and they are not... They're not under the control of you wanting them to contract. They just do it on their own. They require a lot of fatty acids, right? A lot of sugar. I'm just going to say glucose. And these are primarily oxidative cells, so they're going to require a lot of oxygen. So one of the things that just occurs when these things can no longer get to the cell is the cell still needs to contract and it still needs energy. So it is going to stop using fatty acids. It is going to stop using oxygen, and it's going to primarily use glucose. So the heart cells, or the cardiomyocytes, will move to anaerobic glycolysis. And that's not a good thing, because this should primarily be an aerobic muscle cell. And because of changes, it moves to an anaerobic metabolism. And this is going to produce a lot of lactate. I'm just going to put L, right? And a lot of lactate is going to change the pH environment of the heart, meaning that lactate is acidic, so the pH is going to drop. And then we're going to have a low pH in the heart, which is going to feed back and cause more problems. So these are compensatory mechanisms, right? Under normal function, we want fatty acids, some glucose, right? Because when you start to exercise, you're going to start to metabolize glucose. You want lots of oxygen. This is an oxidative cell. But when problems start to occur and these things can't get in and they can't work and they can't do what they're normally supposed to do, there is a compensatory response where the cells say, okay, I can't use what I normally do. Let's shift to only glucose, and let's start moving into an anaerobic metabolism. So there's the compensatory response. And then we start to develop lactate. Lactate is highly acidic, and lactate will drop the pH. And then we have more problems in this cell, which is going to cause more compensatory feedback systems to activate, right? So we turn on this really aggressive and dangerous cycle where changes occur. The body responds with a compensatory mechanism. That's going to cause more changes. The body responds with a compensatory mechanism. That's going to cause more changes. And this is how a disease begins to exacerbate. So I just wanted to kind of present that to you. So much like the chronic heart failure, when a myocardial infarction occurs and these cells can no longer get the nutrients and the oxygen that they need, this results in a substantial decrease in blood flow through the coronary artery. So now the major difference between myocardial infarction and chronic heart failure is we're going to see changes, substantial changes in the movement of blood, substrates, red blood cells, and oxygen through the various coronary arteries. So this is a condition that is really kind of isolated first within the heart and then moves outward through the rest of the body. So it's going to essentially deprive the myocardiocytes of necessary oxygen for a long period of time. And this will ultimately lead to the permanent destruction of these cells, right? And we can look at this picture here and we can see that we are talking today about the myocardium. And let me just let's see what would be good. I think green would be good here. So we're talking about these muscles here, right? We're talking, that's up here as well. We're talking about these skeletal muscle cells that are responsible for contracting, that are responsible for delivering blood through the rest of the body. And what's going to happen is that these are going to get destroyed due to substantial decreases of blood within the coronary artery. So there's a lot of different mechanisms here at play, and we're going to talk about them. So again, we're looking here at all of the contracting muscle within the heart. We're looking at the myocardium, this muscle layer, and what happens to this muscle when it begins to go through necrosis and it begins to perish because of lack of oxygen. So what I'm going to do with today's lecture is I'm going to do a lot more drawing than normal. But just keep in mind that what I'm drawing is following these slides sequentially. So everything we are going to talk about today is going to be following these slides, but we're going to do most of it through drawing. So ultimately, let me just finish this last slide and then we'll move to the drawings. When we begin to have complications with these muscle cells beginning to perish, well, then we get myocardial infarction. So you can see here I have my left anterior descending artery, which is right here. I'll just kind of draw it, right? And when this becomes blocked, and you can see right here I have something blocking it, what begins to happen is that all of the tissue, or the myocardium here in pink, begins to perish. It begins to undergo necrosis, right? And it's all because of this little thing that is blocking blood flow to the myocardium, right? And once all of this begins to perish, why is that problematic? Well, if you're looking at this particular picture, you may notice that this is the left ventricle, which is responsible for contracting and shooting blood out through the rest of the body, out of the aorta here. Well, if the left ventricle is beginning to undergo cell death, well, you could imagine that we're not going to get much blood pumping out, and we will have a complete loss of contraction to this area here, depending on how big the blockage is. So you can see here, this is normal muscle cell, right? These are myocardiocytes, and here you can see, I'm just going to kind of outline it, you could see that there's major changes in that tissue right here. And this is showing you where a myocardial infarction has occurred, right? So all of this space in here is cell death, right? And this would be a normal looking heart. And then here you can see where we're starting to get some myocardial infarction, right? So you can see the changes in the structure of the cellular environment. And we can see that this is not good, because we want all of these cells contracting in unison, right? That's what the heart does. But when we don't have that contraction in unison, well, then we start to get downstream effectors, which means that the body is not going to get the oxygen that we need. And the cell death that is occurring in the heart is also going to occur other places, because all of your muscle cells and most of your cells throughout your body do require oxygen. So you could see how one little domino, right? That right here, we got this little blockage here, is going to knock down another domino, right? And then this is going to impact blood being spat out into the body, which is another domino. And then if we get down to skeletal muscle that requires oxygen, but it's not getting oxygen, we run into autophagy here, and we start to run into cell death here because of ischemia or hypoxia, right? Which just basically means the lack of oxygen being delivered. So you could see how one little mistake in the physiology is going to cause this domino effect, and the body is going to try to upregulate or turn on compensatory mechanisms to stop this from happening, but it's eventually going to worsen the condition. Okay, so like I said, I'm going to do a lot of drawing on this particular lecture, but just keep in mind that it is following the slides that you have. So you have two sources of information now. So we're talking about myocardial infarction, and this is commonly known as a heart attack. And this occurs when there is this sudden blockage or narrowing of a coronary artery. And this leads to heart muscle damage and heart muscle death. So now some of the stages or the signs or the symptoms associated with myocardial infarction, and you might want to put this on your pathophysiology map, is people will begin to feel intermittent chest pain, where they'll feel like a lot of pressure and a lot of tightness on the chest. They will also get lots of bouts of shortness of breath, lots of dizziness, and in a lot of cases, they'll get nausea. And as this progresses or it gets worse, the chest pain will become more frequent. They will get a radiating pain in their left arm or jaw. That's where a lot of people begin to identify where the pain is located. They'll get excessive or profuse sweating, anxiety. This will come with arrhythmias as well to the heart. So if we're going to look at this condition now, signs and symptoms aside, we have a picture of the heart here. And I told you that this disease is essentially associated with blockages of coronary arteries. So I'm going to just animate a couple of arteries here. This is not an anatomy course, but we got to understand where these things are. So the first one I'm going to show you is this left main coronary artery. And that kind of represents this area right here. Now, the left artery has a couple of different descending branches. So we're looking at this area right here, right? And this is the left main coronary artery. And then you'll notice that there are some descending branches to this left main coronary artery. And we'll talk about those in a bit more detail momentarily. So we also have on the other side over here, the right coronary artery. And you can see that the right main coronary artery is right here and right here. And we have some descending branches as well. But just kind of notice that these arteries cover the entire circumference of the heart, and they even move behind the heart. And since my drawing skills are not that good, I'm not going to even attempt to draw the arteries that are going around the heart. But just understand that the heart is completely encompassed by these coronary arteries, right? And what they're doing is they are essentially supplying oxygen and nutrients to all of the myocardium, or the heart cells, right? This is where oxygen is going to diffuse. This is where substrates such as glucose, fatty acids, and amino acids are going to get taken up into the cardiomyocytes. So we have these branches that basically ensure that all of the muscle surrounding the heart is receiving lots of oxygen, right? And I'm just kind of drawing these arrows to show you the direction in which oxygen is going to diffuse and where the substrates are going to also get into the cardiomyocytes to be metabolized. So I'm going to take those away now, and you can see that these coronary arteries ensure that the heart is encompassed with lots of blood to deliver oxygen and substrates, and also to remove waste, right? These are all really important things. Now, over here, we have another branch called the LCX, which is the left circumflex artery, right? So that kind of also goes behind the heart. And then over here, we have another artery called the RCA. And again, this is not an anatomy lesson. I'm just showing you all of the potential locations that blockages can occur. Because if we have a diet that is rich in fatty acids, a diet that is rich in triglycerides, a diet that is rich in saturated fats, well, that leads to the development of conditions which are going to potentially block some of these really important arteries, right? And depending on where these blockages occur, that is going to impact which part of the heart is going to experience this cell death, right? So I'm going to take these away and just trying to get you to understand that these blockages can occur anywhere. Here's another one here. If we look over here, we also have arteries that supply blood to the SA and the AV node, right? So blood is being delivered everywhere, and this is really, really, really important. Now, when we're talking about blockages and we're talking about myocardial infarction, then what we're really talking about here is a decrease in blood flow or a severe reduction of blood flow through these arteries. So if I have an artery right here, then we're asking, well, what are these things that might be causing blockages? And there's a bunch of different things that can cause blockages. The most common one that is causing blockages is, you've guessed it, it's plaque, right? So here you can see in these arteries that we have blockages. And what these blockages are going to do is it's going to reduce blood flow, it's going to increase blood pressure, it's going to reduce the delivery of oxygen, it's going to reduce the delivery of substrates, it's going to reduce the removal of waste from the cardiomyocytes because they are metabolizing substrates, so there's going to be CO2, there's going to be other sort of waste products that need to be taken away, and these blockages are going to cause problems. Now, what are the blockages related to? Well, if you look in your slides, I have a couple of things that I talk about in the slides, which are essentially your lipoproteins, right? So we talk about chylomicrons, we talk about VLDLs, we talk about LDLs, we talk about HDLs, right? If you were to get a blood chemistry test, you're always getting measurements of these LDLs and VLDLs. And what are these? These are essentially proteins that are going to carry lipids in them, right? So if I let me just bring up a clear sheet here, and let me clear all of this out for a moment. So if we are going to eat food like the Western diet that is high in fatty acids, that is high in sugar, that is high in processed foods, well, all of that food has to go somewhere. And essentially, the first place it's going to go to is, we're just going to do a hard and fast lesson here. The first place it's going to go to is going to be our liver, right? So here we have a picture of the liver. And we have all of this food stuff coming in. So I'll just say fat. I'll say carbohydrates or sugars. I'll say amino acids, right? We consumed all of this food, and now all of these things are going to have to go to the hepatocytes or the cells in the liver to get either stored as glucagon or glycogen, right? So if we have sugar coming in, that's going to get processed and stored as glycogen. So I'll just put glycogen, right? Fatty acids will come in and get stored in the liver, or they'll be sent out. And this is where those vesicles are LDL, which is a low-density lipoprotein, our HDL, which is a high-density lipoprotein, and then our VLDL, which is very low-density lipoprotein. These are the packages in which fat is placed into, and then those are sent out through the rest of the body. So this is how we get fat deposited into our skeletal muscle. This is how we get fat deposited into our adipose tissue. This is how we get fat deposited into different places in the body, is that the liver has to identify the fat. And let's just say that we had a we had pizza, right? And pizza has a tremendous amount of fatty acids, tremendous amount of triglycerides, tremendous amount of cholesterol. Well, once that pizza gets into the liver, the hepatocytes have to package it and send it out. And what begins to happen is we get these harmful low-density lipoproteins like HDL and LDL, and they start to increase in the circulation. And this is why they take those blood tests, because when we see a lot of LDL and a lot of VLDL, and again, these are just proteins that are carrying all the fat that we've ingested, well, then what we see with that is an inverse relationship to HDL, right? And HDL is the type of protein that wants to pick up fat from the body and bring it back to the liver to be metabolized, right? So when we have this increase in LDL and this decrease in HDL, that means that more fat is being deposited throughout the body and less fat is being taken away and being metabolized. So this is what begins to lead to, this might be one of the initial injuries that leads to myocardial infarction, and that leads to changes in the heart because of all of the food and fat that we are consuming. So this condition truly stems from poor nutrition and lack of movement or lack of exercise, right? So what's going to happen now is these LDLs that are in circulation, they become problematic in the development of myocardial infarctions. And these LDLs are going to be one of the primary things that causes the blockages that we have been talking about. So let's look really quick at these cardiomyocytes. So if I just did this kind of cross-section analysis of skeletal muscle, so let's just say I pulled out, let me close this, let's just say I pulled out a chunk. Right? We did a biopsy right here. We do not want to do biopsies on the heart, but let's just say I pulled out this chunk of heart and we looked at it. We would see a couple of different layers, right? And I'm not really too concerned with these layers because, like I said, it's not an anatomy course, but this is what's in your slides as well. So we see a couple of these different layers here, right? Then we get some space. And then once we get to the space, we get to this myocardium here, right? So if I pulled out a section of the heart, you can see that most of the heart is composed of this muscle, right? I mean, look at all of this muscle here, right? And all of this muscle is susceptible to loss of oxygen or reductions of oxygen due to these blockages, right? So your heart is a muscle. 98% of it is muscle. The other 2% of it is these connective tissues and these different pericardiums. And all of it is susceptible to infarction or cell death because of the blockages that are going to occur in the coronary arteries and the plaque buildup that is going to be causing narrowing of those coronary arteries. So let's take a look at what this means. So the myocardium, all of that muscle tissue, right? I just kind of showed you right here. All of this tissue requires a couple of different things. They require oxygen, check. Require substrates, check, such as carbohydrates and fatty acids, right? It has to have these things to survive. And if it doesn't have these things, or there is a reduction of these things, there will be compensatory mechanisms that turn on to try to regulate this reduction in oxygen and this reduction in substrates. But after a while, that is going to not work and we're going to get cell death. So this myocardium, everything that we've seen here, is going to start to perish. And depending on where it is, if it's on the right side of the heart, the left side of the heart, central to the heart, if it's here, it's going to severely impact right atrium and right ventricle. If it's here, right, if it's one of those arteries here, it's going to severely impact left atrium. If it's down here and we get a blockage here, well, that's going to severely impact left ventricle, right? So depending on where the blockage is, right? If it's behind the heart, oops, sorry about that. If it's behind, what did I just hit? There we go. This is what I'm looking for. If it's behind the heart, it's going to impact contractility in the back, right? So blockage due to what we're eating, right? Our diet, due to an excessive amount of LDL and HDL being mobile, LDL and VLDL, right? These proteins carrying fats, they're going to basically cause some of these blockages. All right, so let me clean this up, make sure that we're just kind of getting everything that we need to understand. Okay, that looks pretty clean. Okay, and let's move on. So I'm going to zoom in here, and here we can see an artery. And let's say this is the left artery, right? The left central artery. And then we got the descending artery, like right around this area here. Doesn't matter. We're not doing an anatomy course. But let's say we get some blockages in here, right? Well, these blockages are going to cause restriction of oxygen. And I'm beating a dead horse now, right? Because we're going to get a buildup of plaque. There's other things as well that will impact this blockage. And these things are going to be progressive, right? Once we have plaque floating around, it becomes progressive. And not only does it become progressive, but it also can break away and cause blockages within the blood-brain barrier or other parts of the heart, right? This can lead to stroke. This could lead to heart attack. This could lead to the widowmaker, right? A full-blown heart attack. So these blockages can occur anywhere within the coronary arteries. I'm just showing you the left side because the left side seems to be the most common and the most typical, but it could also certainly happen within the right side as well. Those are a bit more rare. So that makes sense, I hope. And let's show what the result of this will be. So when we get this blockage, we get something called ischemia or ischemic conditions. And what this means is essentially that we now have low oxygen being delivered to the cells that are near the blocked site, right? So if we have a blockage down here, we have low oxygen. If we have a blockage here, we have low oxygen. And what does that mean essentially? Well, let's just beat a dead horse. If we have, let me go to yellow. If we have a blockage here, well then all of this tissue here is going to be deprived of oxygen. All of this, right? And all of this tissue here will now start to go through ischemia and cell death. If we have a blockage here, well then all of this tissue, all of these cardiomyocytes here will undergo ischemia and will start to undergo cell death. And the same thing down here. If we have a blockage down here, all of this area here will start to undergo ischemia and start to undergo cell death. So this is the initiation of myocardial infarction, right? We get this blockage, we get the LDLs that are blocking the coronary arteries in certain places, and this leads to the second injury, which is going to be inflammation and the secretion of free radicals. And I'm going to draw that in a lot of detail momentarily. All right, so we've talked about what myocardial infarction is. We've talked about this first hit, this first injury, this first domino, which is kind of the appearance of this atherosclerotic plaque, right? This plaque that starts to build up and cause blockages. So how does this worsen? How does the presence of this plaque worsen? Well, it's a story about endothelial cell injury. And we're going to start by looking at this left anterior descending artery. And I'm kind of zooming in on it. You can see here that it's, I really zoomed in on this artery here. Oh, hang on, something popped up that should not have popped up. Where did it go? Sorry about that. My it's acting a little screwy today, and I'm not sure why. There it is. Okay. So where is this artery? Like I said, this left artery, this left anterior descending artery, is the one that is most commonly impacted in myocardial infarction. So I'm just going to put it up here so you can kind of see it, and then I will identify it for you in a minute here. So if you look here, this LAD, let's go here and let's go here. If you look at this LAD here, that is this artery here. This is the left anterior descending artery. And just look at which part of the heart it is going to impact. It's going to impact that left ventricle, which we talked a lot about in chronic heart failure, right? We said that the left ventricle, the myocardium, those heart cells around the left ventricle, they will start to get bigger, right, and undergo hypertrophy. And once they undergo hypertrophy, that impacts the amount of blood that can fill that left ventricle, and it also impacts the amount of snapback that that left ventricle is going to have because the muscle is too big. And then we know that it's going to decrease over time and get atrophy, right? I'm just going to put atrophy here, right? So that left ventricle in chronic heart failure is severely impacted by overcontraction and hypertrophy of the left ventricle myocardium, and also atrophy of the left ventricle myocardium. Well, in this state, when we're talking about myocardial infarction, we're talking about the same sort of area, okay? We're talking about that, but now we're focusing on purely this artery right here and blockages that can occur along this artery and cause some really bad things to happen. Well, what is going to occur? So what is an endothelial cell? If you don't know, it is okay. Endothelial cells are your cells that line the arteries. So your arteries are composed of this lining of endothelial cells. And you can see here that I just put a couple in there just so you can get an idea of where they are. But you can see that all of these, let me get rid of this, all of these cells are we're kind of right here and right here and right here, right here. And all these cells function together, right? Now, on the outskirts of those endothelial cells, and I'm just going to kind of color this in right now, this is where all of your myocardium is, right? So these cells, let me just draw this in, right? This is all the myocardium here. You can see that I'm coloring it in. These are those muscle cells, these cardiomyocytes, that are right on the exterior of that artery. So let me just kind of draw this in here. Let's give it just a little bit of detail, right? So we'll put some striations in here so that you can understand that the myocardium is on the outskirts of that artery, right? So I'm just going to say, I'm going to put MC for myocardium, right? And the same thing is true for this side. We have all the muscle cells on the other side as well, and we are relying on red blood cells that will be coming through the coronary artery and dropping off oxygen, right? Because all of these myocardiums, or all of these myocytes, require oxygen delivery, right? So it's a really important structure that we need to keep in mind. So let me clear out those red blood cells, and let's now show, sorry, let me go back here. Okay. We can also get this accumulation of fat and lipids in these arteries. And you can see here I drew one. I'll just draw another one just to kind of show you here. So these LDLs are also circulating through the arteries. And the poorer our diet, the more of these LDLs, let me just color them in with this gross fat color here, the more of them are going to be present, right? And I'll just kind of say that these are LDLs. I'll say LDL, right? So these are also circulating with red blood cells through these arteries, and this is what can be problematic. So let me just clear this off. Let me clear this off. Okay, here we go. You can see now that these LDLs are in circulation. They are in the coronary artery, and these are going to interact unfavorably with these endothelial cells. So like I said, the first hit is the presence of these elevated LDLs. That is the first domino. The second hit is going to be how these endothelial cells interact with the presence of all of these LDLs. So these cells are going to respond unfavorably to the presence of all of these LDLs. So I hope that is making sense. And what is going to occur is this accumulation of LDL. If we scroll down here a little more, it's going to start making plaque formation, right? So if we're looking back at this, we can see that as this artery begins to descend down here, right? That's where I'm at here. We're starting to get this plaque formation, right? Because of this elevation in low density lipoproteins, right? And this plaque formation, obviously, as you can see here, is causing unfavorable changes to the coronary artery because now we get this narrowing. You can see how, let me turn it that to black. You can see how this artery has been kind of artificially narrowed, and we have this blockage here, right? Which means that anything past this blockage, so any myocardium past this blockage, is not going to get oxygen. It's not going to get substrates. It's going to be very, very, very reduced. So that's going to cause a problem for all of the myocardium. Sorry, I'm multitasking here. This is not an easy task. That means that all of the myocardium down here is now going to undergo ischemia, which means we are going to get poor oxygen perfusion, and that's going to be really problematic for all of these cells. So again, this is myocardium down here, right? So I'm going to make it striated because those cardiomyocytes are striated, right? So now anything below this blockage is going to be something that is going to get very poor levels of oxygen. So again, here is the arena. We are talking about, let's just bring this back just to make sure that we're all on the same page, right? We're talking about this, this left descending artery. So let me change my colors here. Just want to make sure. It's so hard teaching online because I can't see your faces if you're confused or if you're like, no, I totally get this. So here we go. We're talking about this area here, and that's what I drew, right? It's right here. I drew that. And we just showed that these LDLs are the first hit. They're the first thing to kind of go wrong. A high level of them should not be there. Once they are there, they interact with the endothelial cells, or we can just say the endothelium, which just means all of these cells kind of together here, right? So this would represent, let me change it to black. This would represent the endothelium, right? All of this here, you can see all these cells together, right? That would be the endothelium. These LDLs are going to interact unfavorably with the endothelium, and it's going to cause problems for skeletal cardiomyocytes, right? So the muscle of the heart. Let me take this away so we understand where we are. So now I was bringing up this oxygen piece, right? So I was saying that oxygen is really, really, really important for cellular respiration, and especially cellular respiration of the heart. So we know that all of this tissue requires a lot of oxygen, right? All of this myocardium requires a lot of oxygen. So here we have oxygen, and we know that the heart has a large oxygen demand. And basically, when we don't get that oxygen, we're left with a problem where what the heart needs is elevated and what the heart gets is decreased. So we have this imbalance, just like we did with chronic heart failure, where the needs of the heart are not getting met by the capability of the heart, and that comes from this plaque formation, right? So we have this plaque formation now, and it is severely decreasing the oxygen delivery, and that is not meeting the demands of the heart. And this is leading to ischemia, right? And this ischemia is now going to come with another set of complications. So let me clear this out, and then we will move on to the next section. Let me get rid of the plaque here. And let me clear this out right here. That's gone. See you later. That's gone. That's gone. Okay. And then let me clear this out. So now, here we are again. We have this blockage, right? We have this plaque. Now, plaque is not the only thing that could cause these blockages. You also have a tremendous amount of platelets circulating in the blood, and in the presence of plaque, and in the presence of inflammation, and in the presence of complications surrounding coronary artery dysfunction, we can get platelets that also coagulate, and they can cause blockages, right? And we call that a platelet plug. So we could have plaque that's causing these blockages. We could have platelets that are causing these blockages, and platelets are going to play an important role later on when we talk about this remodeling of the coronary arteries due to inflammation and due to this plaque. And, well, of course, we can have red blood cells that are also causing blockages. We call that thrombus. And when we have plaque, we generally tend to have thrombus as well, which is this blockage that is caused by red blood cells accumulating. All these things can happen together, or they can happen independently. One can induce or initiate another, but in the state of, when we are in the state of overnutrition and we're eating poorly and we're having a high fat diet, well, all of these things work together and they cause this ischemic condition, right? We have a decrease in blood flow. That is problematic. You guys are well aware of that because I've just been mentioning that quite a bit, right? So we have this decrease in blood flow. And obviously, we're going to have a decrease in oxygen as a result of that. We're going to have a decrease in cellular function. Well, now you're saying, well, which cells? You told us about two cells. You told us about the endothelial cell, which are the cells lining the arteries. And then we also got the myocardial, which are the heart muscle cells. Well, both of them are going to be impacted negatively. And then we're going to have a decrease in substrate delivery, which means that the heart is not going to have the fuel that it needs in order to keep pumping successfully, right? So these things are all going to cause problems. And the substrates is going to cause a really interesting problem, because what happens here is the heart, the muscle cells in the heart, they have a lot of mitochondria, right? They are mitochondria rich, which means they preferentially want to use oxygen as their fuel, right? And if they're going to use oxygen preferentially as their fuel, let me get this one here, right? They want oxygen. Well, then that means that they're going to metabolize carbohydrates oxidatively and fatty acids oxidatively. So those are their primary fuels. Those are their primary substrates, but they have to have oxygen in order to do that. And all of these are going to enter the mitochondria. And what they're going to do is to create ATP. Why are they creating ATP? Because the myosin and actin in the cardiomyocytes require ATP so that they can contract, right? That's how myosin and actin interact. They form that cross bridge, they form that power stroke, and then we have contraction of the heart. So when we have these events all occurring, we get these blockages, we get a decrease in blood flow, we get a decrease in oxygen. Well, now we're going to have compensation. And I mentioned earlier that it's going to compensate. It's going to try to come up with a overcompensation mechanism to fix this. Because if all of this is decreasing and we're not getting oxygen and we're not getting substrates, well, now we're not getting ATP, and that is going to be problematic. ATP production in the heart is going to drop. So what the what the overcompensation mechanism that is going to occur is that the heart will now switch to, if you look up here, anaerobic metabolism. It is no longer going to metabolize aerobically because this system is faltering. And it is faltering because of the plaque or the platelet plugs or the thrombus or all of it together. It is all faltering because the blockage is stopping the physiology from occurring. So what else is going to occur is we're going to get ion delivery is going to be decreased. And as you all know, cells require lots of sodium and potassium and chloride. And they're going to require these ions to assist with depolarization and contraction of the heart. So not only are these blockages here stopping the mobilization of oxygen in red blood cells, but they're also decreasing ion delivery, such as your Na2, Ca2 plus, right? Potassium, right? So all of these things are now being reduced in delivery, and that is going to further complicate myocardial infarction, right? So you can see how all of these things are kind of making the situation worse over time, and how an alteration in blood flow is leading ultimately to an alteration in energy production. And that's really, really important in the heart, that we maintain normal energy production, because we want to maintain ATP production, because the myosin and actin in the heart require ATP in order for the heart to contract. So I'm almost done with this lecture, because I know this is a lot of material, and what I'm going to present to you on Thursday is going to be even heavier. But do not fret. We will get through it all together, I assure you. So what we're going to talk about now is a couple more injuries that can occur. And it's really important to understand that the way these conditions get worse is that they start to compound. So now you can see I have this overlapping of injuries here, right? So we're going to focus not really on thrombus. We're not really going to focus on platelet aggregation. We're going to just kind of focus on this plaque, right? But it's important to know that plaque, thrombus, and increases in blood pressure can lead to something called vasospasms, which makes this all much more dangerous. So what is a vasospasm? Well, if we look at another descending branch of one of the arteries, we can see here that we begin to get this swelling of one of the arteries, right? And this swelling is not a good thing, because when we have plaque, thrombus, vasospasms, and then increases in blood pressure, that makes this vasospasm very dangerous, because what can happen is this can rupture. And you can see here that here we have this rupturing of a coronary artery branch, and now we have red blood cells that are leaking out into the interstitial space of the heart. And this causes a lot of problems as well. So all of these things can overlap and create a lot of complications for the heart. So let me just clear this out here. And we're going to go back to this plaque formation. We know that all of these injuries are going to overlap. So here we have endothelial cell injury. We've been talking about this most common injury, which is the plaque. And we're going to talk about how this injury that starts with plaque formation, that starts with LDL, increases in LDL, circulating LDL, are going to interact with the endothelium cells, or the endothelium, and this is going to cause major changes that we would see clinically in heart function. So first and foremost, we will have dynamic heart pressure. So when we have these overlapping injuries, heart pressure, atrial pressure, ventricular pressure, aorta pressure, preload, afterload, ejection fractions, all of these things are going to be impacted by the presence of this plaque, the plaque interacting with endothelium, the endothelium causing dysfunction, which is then going to impact the myocardium, right? So all of these things are overlapping injuries. They're all associated with each other. And one of the first things that's going to happen is we're going to have this change in heart pressure within the different parts of the heart. And that's not good because your body is just like when you exercise. If you have an increase in pressure, if you have a decrease in pressure, there are compensatory mechanisms that try to either maintain it at a healthy level or bring it back down to the basal state, right? Homeostasis. Now, another thing that can happen is we're going to have dynamic plaque formation, which means that plaque that may have started here or here can break away and move to different parts of the body and cause damage there. And since since LDL is elevated and the diet has not changed, we will constantly get new plaque formations in different places. So the plaque formation portion is also dynamic, which creates a problem for the body because it is trying to keep up with the changes that the plaque is inducing, right? And it's always going to be a couple steps behind because the plaque formation has to be there for long enough to cause some sort of damage where the body can pick up on it and say, okay, well, now we have plaque forming here. We have thrombus forming here. We have platelet aggregation here. We have inflammation here. We have free radicals here. And now another area of the myocardium is being impacted, right? So you have this constant fluctuation in pressure within the heart. You have this constant fluctuation of plaque formation and plaque dislocation, right? All of these things are happening at the same time. We also have, so I just put that there, plaque dislocation. You can see that there, right? I just kind of talked about that. So we'll have the breaking away of the plaque. But now we're also going to get chronic inflammation. And this is really problematic as well because the plaque formation, the chronic inflammation, the plaque dislocation, and the heart pressure and changes in all of the pressure is eventually going to lead to cell death and necrosis because we have ischemic conditions, we have blockages in the heart, we have changes in pressure, we have inflammation, we have the body trying to compensate for the changes in heart function, and all of this leads us down a really, really dangerous pathway. So I'm going to stop here for lecture 1. I will finish lecture 2 on Thursday. It is going to be heavy in, some of these mechanisms. That's okay. We'll draw it. And we'll talk about how exercise can favorably curb myocardial infarction. If you're kind of on the continuum and you're in the early stages of developing it, well, exercise can come to the rescue and certainly save us from going into a full-blown heart attack. And we'll also talk about how exercise can be used as recovery from myocardial infarction. So that stuff will be coming down the pipe on Thursday. So I'm going to stop this lecture here, and then I hope you all have a great week.